Buildings remember things people forget. Skyscrapers remember in their skin. In the thousands of narrow seams between concrete panels, 30 stories above a sidewalk full of people who never look up. Marguerite Solano had spent 24 years learning to read that skin inside the Holloway Tower, a 1974 32-story downtown office building clad in precast concrete panels. Its curtain wall sealant system inspected and partially recaulked on a rolling maintenance cycle ever since it first opened. She was 59 now, building envelope technician, responsible for the unglamorous, life safety critical work of making sure an 18-inch slab of concrete 30 stories up never had a reason to come loose above the busy pedestrian sidewalk below. She had learned to trust that skin from a man named Harlan DeVries, who had inspected the tower's envelope for 22 years before her and who believed, without needing to argue the point, that a building's skin told you everything about its skeleton, if you were patient enough to read every single seam. Marguerite started at Holloway Tower at 35, hired as DeVries' assistant during a period when the building was still debating whether a dedicated envelope inspection position was worth the budget at all. DeVries was 60 then, methodical and unhurried, a man who could stand at the base of the tower with binoculars and tell you which panel needed attention before the rope access crew ever got close enough to confirm it. This skin is the only thing standing between 18 inches of concrete and sidewalk, DeVries told her during Marguerite's first week, the two of them riding the rope access rig down the tower's northeast face for a routine inspection. People walk under this building every day without thinking about what's holding it together. That's fine. That's what it means to do this job well. Nobody down there should ever have a reason to look up. DeVries kept a panel-by-panel inspection map. Every joint on the tower numbered and dated. Condition notes accumulated across 2 decades. He believed the building's exterior was a document, and somebody needed to be reading it seam by seam rather than glancing at it from the ground and assuming it looked fine. Marguerite remembered the first time DeVries handed her the map, unrolling across a table in the mechanical floor office and tracing a finger down columns of numbers that meant nothing to her yet. She'd asked, honestly overwhelmed, how anyone could possibly keep track of every single joint on a building this size. DeVries had rolled the map back up slowly before answering, the way he did everything. You don't track every joint the same way, he'd said. Most of them you check and forget because they behave. The ones worth remembering are the ones that keep coming back to you. This map isn't really about the building. It's about which parts of the building refuse to stop talking. When DeVries retired, he left Marguerite the map, along with a piece of advice she had carried for 24 years since. Don't ever let a panel earn your trust just because it's quiet. The ones that need watching are the ones that keep asking for attention, even a little more than they should. Holloway Tower had been built in the confident, efficient style of 1974, a grid of precast concrete panels hung on a steel frame, each panel separated from its neighbors by a narrow sealant joint designed to flex with the building's natural sway and thermal expansion without ever letting water or air infiltrate the structure behind it. The original sealant, like most curtain wall products of its era, had a useful life measured in years rather than decades, and the building had operated on a rolling recalking schedule since its first decade of service, working methodically through thousands of joints across the tower's face. Marguerite knew the towers skin the way she knew her own hands. She knew which panels on the south face weathered fastest under direct summer sun, and which corner joints needed extra attention after a hard winter. She knew the particular sound rope access gear made against concrete, and the smell of fresh sealant curing in the open air 30 stories up. She knew which sections of the map DeVries had annotated in his own careful hand, and which she had continued in her own since. And she knew, better than anyone alive, that panel 8 to 14 on the tower's northeast corner at the 8th floor had always needed sealant replacement roughly twice as often as any comparable panel in the building. It wasn't dangerous. Not yet, and not in any way visible from the ground. Pedestrians walking beneath the tower's northeast corner had no idea anything about that specific panel differed from any other square of concrete on the building's face. Office workers on the 8th floor walked past the interior side of that same wall every day without a second thought, unaware that 30 stories of concrete and steel were quietly conducting a decades-long negotiation just beyond the drywall. But DeVries had noticed, Decades earlier, that panel 8, 14 sealant joints failed and needed recaulking at nearly double the rate of the panels beside it, even though every anchor point tested sound and every movement reading fell within design tolerance. DeVries's earliest entry about it, dated 1991, read, *8-14 sealant failing again, second time this cycle. Panel anchors checked, tested sound. Movement at this joint reads normal on the gauge. Something behind this one panel works the sealant harder than anywhere else on the tower. Watching it, Marguerite had read that entry during her first winter with the map, sitting in the small envelope maintenance office off the building's mechanical floor, and it felt something settle into place that she wouldn't fully understand for years. DeVries had noticed something real. DeVries had never solved it, and DeVries had kept documenting it anyway. Cycle after cycle, patient enough to preserve a pattern he never got to finish explaining. Marguerite continued tracking panel 8, to 14, without ever being asked to. Every recaulking cycle, the same joint, failing faster than its neighbors. The anchor points testing sound every single time regardless. In her 11th year with the map, Marguerite began doing something DeVries's descriptive notes had never quite included. Precise movement gauge readings at panel 8, 14's joint, taken during each inspection cycle rather than simply confirming the sealant had failed again. It took her nearly a decade of those readings to see what DeVries's rougher notes could only imply. The joint's movement wasn't holding steady at whatever baseline had originally caused the accelerated wear. It was widening, a small fraction more each year, slowly enough that any single cycle's reading looked unremarkable, technically still within design tolerance, unmistakable once laid out across 10 years of careful gauge figures. The panel wasn't failing because of a single flaw. It was moving through a slightly larger cyclical range every year, wearing out sealant faster simply because it had further to travel with each sway of the building. She sat with that realization one evening in the envelope office. DeVries's oldest map annotation opened beside her own decade of movement data. The tower quiet around her after the building's daytime population had gone home. 2 people, 1 panel. Over 30 years of the same patient question, neither of them ever quite ready to call it solved, and neither of them ever willing to stop measuring either. If the widening had been happening since DeVries's first 1991 entry, something behind panel 8 to 14 had been quietly, patiently intensified for over 3 decades, never once exceeding code tolerance, never once triggering an alarm on any inspection, but growing more demanding every single year in the one place on the tower's entire face where that demand mattered most. She wrote a new entry beneath DeVries's oldest one, in the same plain hand. Astra's 10 years of movement gauge readings confirm panel 8, 14 cyclical range is not stable. It is widening, slowly, consistently, still within tolerance, but no longer matching neighboring panels. 'Cause still unknown. Continuing to measure, she underlined continuing. It felt like the only honest word available to her. 30 stories below. Pedestrians kept crossing beneath that corner every single day, entirely unaware that the concrete over their heads had been quietly negotiating with itself for 3 decades, in a language only a movement gauge and 2 patient inspectors had ever learned to read. Marguerite had a theory, in her 15th year, that the cause might simply be a degraded backer rod behind the sealant joint. The foam material installed to support the sealant's shape and depth potentially compressed or deteriorated at this one panel in a way that would explain accelerated failure without requiring anything structural. She spent the better part of summer fully replacing the backer rod at panel 8 to 14 during a scheduled recaulking cycle, installing fresh material to exact specification, confident she had finally found something a straightforward materials fix could permanently correct. The joint failed again within the following cycle, at almost exactly the rate her 10-year trend predicted. The fresh backer rod had made no measurable difference. Whatever was driving the accelerated movement wasn't happening in the joint sealant assembly at all. It was happening somewhere behind the panel, in the steel frame and structure the panel was actually anchored to. She had been wrong. She wrote it plainly in the map's margin, in the same unembellished style DeVries had taught her without ever meaning to teach a lesson. Backer rod theory. Ruled out. Fresh material installed. Joint failed again, on schedule. The cause is structural, not in the sealant assembly itself. back unexplained. Asterisk. It bothered her more than most of her wrong guesses did. She had wanted the backer rod to be the answer. Simple, replaceable, a summer's labor and a closed question. Being wrong meant the cause lived somewhere inside the tower's original 1974 steel frame, in a section of structure nobody had opened in 50 years. The full recladding project announcement arrived in her 20th year. Holloway Tower's ownership approved a comprehensive recladding initiative, replacing the sealant system tower-wide with modern, longer-lasting formulation applied uniformly according to the original 1974 design tolerances. The project treated every joint on the building as structurally identical, exactly as the original architectural drawings described them, offering the promise of decades without recalking anywhere on the tower's face. Marguerite read the project brief and felt an old unease sharpen into real urgency. The new sealant, whatever its improved durability, was still rated for standard movement tolerance. If Panel 8/14's joint had been quietly exceeding its neighbor's movement range for over 30 years, a uniform installation assuming identical behavior everywhere was about to face the exact same accelerated wear all over again, just with a longer interval before anyone noticed, and a much larger cost to fix once they did. She brought DeVries's map, along with her own decade of movement data, to the recladding contractor. The contractor, a capable and straightforward man named Foster Adair, reviewed Panel 8/14's anchor bolt inspection and structural certification alongside Marguerite's data at a folding table set up in the building's lobby. This panel's anchors are fully within code, Adair said, reviewing the certification documents. If there were a real structural anomaly, I'd expect it to show up somewhere in the inspection history. And it doesn't. My honest read is a normal statistical outlier. In a building this size, with thousands of joints, some will always run a little hotter than average. The new sealant formulation is rated for significantly longer service life, regardless of minor movement variance. I think it outlasts whatever's been happening here. The movement isn't staying the same, Marguerite said. I've measured it for 10 years. It's widening every single year, even though every anchor point tests sound, and every reading stays technically within tolerance. A statistical outlier doesn't get worse on a schedule. Something behind that panel is still actively changing. Adair considered that, and to his credit, didn't dismiss it outright. I don't have another explanation for a trend like that, but an anchor certification that passes code doesn't give me grounds to treat one panel differently in a tower-wide installation. The project scope is a uniform recladding, not an open-ended structure investigation into one bay's history. It was a reasonable position, and Marguerite didn't have a structural engineering credential to argue against it. What she had was 30 years of a pattern that had outlasted a full backer rod replacement, and a growing conviction that a passing anchor certification and an actually stable movement range were not the same thing. Marguerite didn't sleep well through the weeks that followed. She kept circling back to a question she couldn't put down. What if Adair was right, and 30 years of careful measuring amounted to nothing more than an ordinary statistical outlier in a very large building, a pattern she and DeVries between them had slowly turned into a structural concern through nothing but 2 careers of professional vigilance stretched too far? She had wanted, for years, for the widening movement to mean something real. Wanting it to matter wasn't the same as it actually mattering. She pulled DeVries's oldest map annotation out one more evening and reread the 1991 entry under her desk lamp. Asterisk something behind this one panel works the sealant harder than anywhere else on the tower. Watching it, asterisk. DeVries had never known the cause either. He had simply kept watching, cycle after cycle, trusting that the pattern was worth preserving even without an explanation attached. Marguerite had inherited that trust without ever fully testing whether it could stand against a passing code certification and a reasonable contractor's project scope. She didn't have the cause confirmed. But not having it hadn't stopped DeVries from writing the first entry in 1991, and it wasn't a reason for Marguerite to stop pushing now. Not with uniform modern sealant about to be installed over a joint her own decade of numbers said was still quietly exceeding its design range, 30 stories above one of the tower's busiest entrances. She requested, at her own initiative, a single day with a structural engineer before the recladding reached the tower's northeast corner, not to delay the project. She made clear, only understand what was actually happening behind Panel 8 to 14 before a uniform modern sealant locked the same unexplained pattern into place for another 30 years. The engineer was a woman named Priya Anand, who assessed older high-rise structures for hidden low-path anomalies. She reviewed Holloway Tower's original 1974 structural drawings alongside Marguerite's decade of movement data, and she spent a day tracing the steel frame behind panel 8 to 14 back through the building's structural system, working from the mechanical floor with a laser survey instrument and a set of accelerometers temporarily mounted near the panel's anchor points. What she found explained over 30 years of a pattern that nobody had ever been able to name. "There's a transfer beam right behind this bay," Priya said, showing Marguerite the structural drawing at a table set up near the mechanical floor's access hatch. "It's accommodating a mechanical shaft that runs unusually close to this specific section, a feature unique to this one bay, not repeated anywhere else on the tower's face. That transfer beam responds to the building's normal wind sway and thermal cycling with a slightly different rhythm than the standard framing everywhere else. It's not dangerous. It's just different, and this panel sealant has been caught in the middle of that difference for 50 years. And it's getting more different," Marguerite said. "The connection's aging," Priya said. "As it ages, the differential movement produces is very gradually amplifying. Not enough to threaten the structure, but enough to explain both the accelerated sealant wear and the trend you've been tracking. A uniform sealant, rated for standard movement and applied without accounting for this one bay's actual range, would face the exact same accelerated failure within a few years, right here, above one of your busiest entrances." Priya's findings went to the recladding committee within the week. Foster Adair reviewed her structural assessment personally and called Marguerite afterward. "You were right to push for this," Adair said. "The anchor certification told the truth about what it measured. It just never occurred to anyone that a hidden transfer beam might be giving this one bay its own private rhythm. If we installed the standard sealant here without finding this, we have been back on the same recaulking cycle within a few years, except now it would have been the newest, most expensive formulation failing, right above your main pedestrian entrance." The recladding specification was revised. Panel 8, 14's joint received a custom sealant profile engineered specifically for its actual measured movement range rather than the tower's standard design tolerance, along with monitoring provision to track the transfer beam connection's condition going forward. The rest of the tower-wide recladding proceeded on the original uniform specification, installed over joints that genuinely behaved the way the drawings assumed they would. Holloway Tower's ownership filed a formal note in its facilities archive, crediting both Harlan DeVries' original 1991 observation and Marguerite's 24 years of continued measurement as the reason a hidden structural anomaly had been found and properly addressed before a uniform modern sealant system repeated the same accelerated failure indefinitely. Marguerite kept DeVries' inspection map. She added a final entry beside his oldest one before moving the complete document into the building's permanent archive. Asterisk panel 8 to 14 fitted with custom sealant profile and monitoring this year. Differential movement traced to a hidden transfer beam serving an adjacent mechanical shaft. Documented informally through accelerated sealant, where since 1991. First cycle on record with movement matching engineered tolerance rather than exceeding it. Harlan, you were right. The quiet panels were never the ones to worry about. Neither of us knew what this one was responding to for a very long time. Asterisk. She rode the rope access rig down the tower's northeast face one last time after the new joint was installed, running her gloved hand along the fresh sealant at panel 8 to 14, feeling nothing but smooth, even material for the first time in the building's recorded history. She thought about DeVries, riding the same rig decades earlier, telling a nervous new hire that nobody on the sidewalk below should ever have a reason to look up. Marguerite had carried that sentence through 24 years, through a ruled-out baccarat theory, through a season of real doubt about whether 2 careers of careful measurement had amounted to anything more than professional vigilance stretched past its usefulness. She hadn't needed to understand the cause immediately. She had only needed to keep reading the tower's skin, the way DeVries had taught her, until the building finally explained exactly what had been quietly working its one demanding seam for over 30 years.